Okay, today we are going to look at 2.2 sector areas and segment areas. The first formula that you need to know and to memorize is that the area of a sector is x over 360 times pi r square. So the same concept as the arc length is the proportion of the entire circle times the area. So basically, right, for a smaller angle, you get a smaller area. Then for a larger angle, you get a larger sector area. Okay, just to quickly recap, a sector is like a slice of a cake and it looks like this. Okay, now, so this is the formula that we'll be working with today. We will now move on to page 47, try 5 of your textbook. Okay, so now first and foremost, what we shall do down here will be this. Okay, so we will look at the area of sector OQCD. So OCQD, sorry. So OCQD, the sector will look like this. This is a very simple question, so let's just get right to it. So the area in this case is 237 over 360 times pi times r square, which is 9 square. Just compute that inside your calculator. What you get is 168 cm square, which is correct to 3 significant figures. Okay, I'm now looking at try it 6 now. Okay, be very careful with try it 6. This try it 6, right, we are going to have another term here, which is segment. Okay, I taught you in 6.1 what a segment is. So just imagine, okay, this is a circle. Alright, then if you cut off this portion here, this small thing here is this one here is the minor segment. Okay, while the big one here is the major segment. So today what we are going to focus on for this portion here is the minor segment. Okay, first and foremost, they say that is given that the area of the sector is 64 cm square. So now, how do I make use of this piece of information? I just use the formula that we have just learned, where I say that x, okay, which is angle AOB over 360, all right, is equals x over 360 times pi times r square is equals to 64. Okay, if I work all that out, okay, x equals to 64 times 360 divided by 64 pi. So I will work out to find that x is equals to 114.59 degrees, correct to one decimal place for angles. X is 114.6 degrees. This is angle AOB. Now, if you want to find the area of segment ABP, okay, I already talked about what the segment is. So basically, in a nutshell, what we're doing is we're going to take the area of a sector minus the area of the triangle. Then what we are left with is the area of the segment. Alright, so let's just dive right into that. So first I find area of triangle AOB. Okay, if you remember, the area of a triangle is half AB sine theta. So what I have is half, okay, times, this is also 8 cm, 8 times 8 times sine of 114.59 degrees. So the area of triangle AOB is 29.098 cm square. Now, as I said, okay, to find the area of the minor segment, what I take is the area of sector minus the area of the triangle to get segment. So I say area is equals to 64. Notice I do not need to calculate this 64. Why? Because it's already given in the question that the area of sector is 64 cm square. So I just take 64 minus away the area of triangle AOB, which is found to be this. What I get is 34.9 cm square. That's the area of the segment. So in case you're wondering, this is the area that we have just found. Okay, now I'm moving on to try 7, which is found on page 49. Find the area of the shaded region. Okay, this one, let me just make a few amendments to this. So what actually we are looking for here is the shaded region, but you can't find it directly. What I need to do is to break it up. Okay, so if we were to break it up, what I can do here is I draw. So if you look what I've just drawn here, this is a triangle, okay, and this here is a sector. So what I need, right, is to add the area of the triangle to the area of the sector itself. Okay, now if you notice, if this is 60 degrees, all right, okay, then this and this are both radius, so this makes this triangle an isosceles triangle. So if this is 60, it means that this is also 60. Okay, in essence, this is actually a equilateral triangle. So let me just label this. This is also 60 degrees. Also, what do we know is that the radius of the circle is 10. Okay, that's given really. Alright, so now, okay, let me find the area. Okay, let me just work it out now. So the area of the shaded region is equals to area of triangle AOC plus the area of the sector OBC. Area of triangle, as we have learned from the previous example, we can use half AB sine theta, so it's half AB, so in this case is 10 times 10. Okay, why 10 times 10? If you just focus back on the diagram itself, OA is equals to OB, so OA is 10. And then OA is the radius, OC is also the radius, this is also 10. So it's half AB times sine of 60 degrees. Okay, plus the area of sector. Alright, okay, just now I did not calculate this angle yet. This angle over here is 60 degrees, which means that this angle is 120 degrees. So we apply the formula for the area of sector. It will be 120 over 360 times pi times r squared, which is 10 squared. So if I just use the calculator, I compute everything, I'll find that my answer is 148 cm squared. Now we're on page 50, which is try 8. So what we want is to find the value of x. So basically what they tell me is this: the area of the shaded part, alright, let me find the 2, is 30 pi cm squared. So basically this thing over here, okay, looks like part of a donut or something, is 30 pi cm squared. Okay, so now how do I actually get the shaded area? Okay, so I will first say this, that the shaded region is equals to 30 pi cm squared. So the shaded region can actually be thought of as this. I take the big sector, okay, which is the one I've just drawn, minus away the area of the small sector. Then what I'm left with is this entire area here, which is the shaded region. So let me fill that in. First, the area of the big sector is 144 over 360 times pi times r squared. Okay, be careful for the big one. What is the radius? For the big one, okay, the big sector, the radius is actually this one, 5 plus x. So what I get here is 5 plus x squared. Okay, so I have to minus away the area of the small sector, which is here. So I get is 144 over 360 times pi times, what's the radius in this case? It is 5 squared is equals to 30 pi. So essentially, I've translated the word shaded region into this minus this. The 30 pi just remains. So if I start to simplify my working over here, what I get here is this 144 over 360 gives me 2/5. Okay, so it's 2 pi over 5 times 5 plus x squared minus 10. Okay, pi is equals to 30 pi. If you notice, the common factor here will be pi, pi, and pi. So what I can do is I can divide every term by pi, divide by pi, and divide by pi. So what I get is 2/5, okay, times 5 plus x squared minus 10 equals to 30. So I start to solve. Okay, I will say that 2/5 times 5 plus x squared is equals to 40. Now what I do here is I will multiply by 5, divide by 2. So I will say that 5 plus x squared is equals to 100. Okay, then now I will, in order for me to solve this, I need to square root both sides of my equation. So I will say that 5 plus x is equals to 10, or 5 plus x is equals to negative 10. But in this case, I shall reject the negative 10 because 5 plus x is a length. So you cannot have a negative length, which is negative 10. So I will just reject the negative 10 there. So quickly solving, my x value is equals to 5 cm. Okay, I will now just give you some examples from exercise 2.2. These can be found on page 51. So do take some time to go and flip your book, okay, to page 51, so that you may have a clearer picture of how the question actually looks like. Okay, so now I will start with question 4a. So 4a, what we need to do is this: find the perimeter, okay, of the segment BCD. So what I'm looking for is the arc BDC and plus this length over here. Okay, just some notes. This, if you notice, is an equilateral triangle. So this angle here will be 60 degrees, which means that this side is 5. This side will also be 5 cm. So let me just fill in the diagram. This is 60 degrees. This is 5 cm. So now, the perimeter of the segment is equals to this. Equals to the arc BDC plus the length of BC. So for me to get the arc BDC is 60 over 360 times 2 pi times 5 plus BC, which is 5. So what I get is 10.2 cm. Now, I want to find the area of the segment BCD. So, what is this segment we're talking about? I think we did something similar earlier. This segment is this. So, what I need to do here is to take the area of the entire sector minus away the area of the triangle. What I'm left with will be the area of the segment BCD. Okay, let's just get right to it. So the area, okay, of segment is equals to the area of sector ABDC minus away the area of the triangle ABC. So if I just fill in the values, I get 60 over 360 times pi times r squared minus away the area of the triangle is half AB sine theta, which is times 5 times sine of 60 degrees. If I compute everything, what I should get is 2.26 cm squared. And that's for question 4. Okay, we are now at the last question, which is question 7. Think again, once it looks similar again. First, find the perimeter of the shaded region ABPC. Okay, so maybe you can think of it again. What I did in the previous question in the try it was to divide out the diagram. So same thing, I will divide it out here. Okay, if I drew something like this, so what I get here will be a sector, which is OBPC, and a triangle, AOC. Okay, now, so the perimeter of the shaded region will be made up of, first, I need BPC, okay, the arc, okay, then I need this 8 plus 8. AC might be slightly more difficult to do, but we can still get to it. So just give me one short moment, okay, we can try to find the angle, the side AC. Okay, first and foremost, if this AO and CO, they are both radius, is a isosceles triangle. There are actually two ways to do this. One way to find AC is actually to use the cosine rule. Another way is to drop a perpendicular down. You can find AM, and then you can find MC. Then you can add the two together to find AC. Alright, so now why don't I just do, I'll try to find AC, I will use the cosine rule. So first and foremost, I will find by cosine rule, I'll say this, AC square is equals to 8 square plus 8 square minus 2AB cosine. Alright, forgot to find the angle just now. If this is 35, this is also 35. It makes this angle 110 degrees. So here is minus 2AB cosine of 110 degrees. So if you very quickly, AC square, okay, I don't have AC square already. I'll just say that AC is equals to, if you just do your computation, you find that AC is 13.1064 cm. So I found AC. Now, next thing I need to do is to find the arc BPC. So the length of arc BPC will be theta over 360 times 2 pi r. So if I will just take a look here, this was 110 degrees. It makes this angle here 70 degrees. So now, if I'm trying to find the arc of BPC, I'll say it's 70 over 360 times 2 pi times 8. So what I'll get here is 9.7738. So if I just add, okay, just look at the diagram for a while. AC is 13.1064. BPC is 9.7738. This is 8 cm. This is 8 cm. This will give me the perimeter of the shaded region. So now I will say that the perimeter is equals to 13.1064 plus 9.7738 plus 8 plus 8. So my perimeter will now be 38.9 cm. Okay, now for part B, alright, is something similar to what we have done, so I won't spend so much time. I say that the area is equals to the area of triangle AOC plus the area of sector OBPC. So area of triangle AOC, we apply half AB sine theta plus the area of sector OBPC, which is 100 and which is equals to 70 degrees over 360 times pi times r squared, which is 8 squared. So if you compute everything, what I should get down here is 69.2 cm squared. And that concludes this portion of the lesson. Please refer to class.